So, hi there. With this video I'm trying to explain why it is currently so exceptionally warm. This is not the first time this happened. This happened a few times in the last years. And how these incredible temperatures are possible. We got here 27 degrees at 800 meters. Theoretically, that would be the same as 35 at sea level, and this is winter. So how is this actually possible? The situation is the following. We got the typical situation in the atmosphere 6 kilometers above the ground. There's cold area, there's a cold zone here, all this northern zone coming from the polar, from the temperate area, the cold air, and this air here is coming from the tropics, spreading out from the tropics, and between there's this very sharp border, usually defined as a jet stream, where there's high winds and where also these cyclones are formed. There's a contrast between the tropical air coming up from the south and the colder air coming down from anywhere north. And and this can suddenly make a wave. Instead of going west-east, it makes these waves, so it suddenly goes up like this. And the cyclones now are moving far north, for example, over Britain, and Spain gets totally in this warm area. And in high level, this is already high pressure, because this is warm, less dense air from the tropics. Goes a bit too far to go into more detail, but even like we currently have, it can even, the wave can even get stronger. So even in this level, we already get a high pressure zone. There's, it gets close to the Greek letter omega, making this shape, and getting a very stable high pressure area, because this wave has just extended itself and extends quite far north. So what happens when we go down to ground level? Because the air that is lying underneath is obviously still from winter, it's still kind of colder, so it's cold, and cold air is more dense. It is a heavy, cooler layer under this already kind of relatively high pressure. So we go, the further we go close to the ground level, the high pressure increases. We get like a mountain of air. So here we got a relatively high pressure on ground level, and this is what I call the subtropical anticyclone, or it's normally called like this. The Azores high is also subtropical anticyclone. So in the higher areas, higher levels, it's air of tropical origin, and in ground level we get a cooler layer formed over the ground, and we get this very high pressure. And what does the air, obviously, following gravitation, looking at this as a mountain of air, obviously the air flows away from the mountain. It flows, wants to escape it, wants to flow out of it towards low pressure. The same as you would drop a bucket of water on a flat surface, the water would try to run away into all directions. And the same is happening here to this anticyclone. Now, here in the center area, and we are about here, it can't. What happens here? The air is going away into every direction. Like this would be the pressure center. The air is going away in every direction. So the only way that this air can be replaced is it comes down from above. And that is, if you know these old-fashioned cigarette machines, sometimes they're still there, where you can pull out a pack of cigarettes at the bottom, and then the other cigarettes fall down from above to replace it. And it's the same that happens here. So this level on the ground level is removed, this air on the ground is removed, and this warmer air falls down to replace it. And by falling down, it by a law of physics called the so-called dry adiabatic gradient, it is warming 1 degree per 100 meter. So the more strong and long this situation continues, the more this warming and drying effect becomes active. So, and as we know that the air that is in higher levels is coming from the tropics, we can imagine that this air gets exceptionally warm. It is actually not the sun that is making this. The sun is not strong enough for these temperatures. We are in the middle of winter. So actually we are getting this air from the tropics slowly sinking down to create these warm temperatures. Normally, though, we don't get these warm temperatures at ground level. Normally they're only maybe affecting the mountains, because obviously in ground level this air is still in contact with a cold ocean or with a cold long winter nights, and it will lose its temperature, it will just cool down, and so we get this cold layer close to the surface forming, and the warm layer lies on top of it. So we can usually get this very strange situation here, that we have these exceptionally warm temperatures here, 16 degrees and 2000 meters. We have plus 16, and suddenly underneath we get this cold layer. For example, over the Mediterranean, we have only, we have much colder conditions. You go here, suddenly you're in 1 kilometer, you have 5 degrees, and then you climb up another and you suddenly have plus 16. So it's called a thermal inversion. So suddenly it gets a lot warmer if you get higher. And this is also very, very stable. It's impossible to create any rain. You can have fog, but not any rain, because this cold air, when it would move up, it would get even colder, and it would be heavy. It would immediately sink down again. It cannot go anywhere, so it's trapped underneath. So now the very strange situation that happens here in the Alpujarra, looking at this now, is usually we would have maybe here, this is the cold layer, and we would have the warmer layer on top. But because our area is a very strong south slope, this is like the Contraviesa and then Sierra Nevada, it's a continuous long south slope. So the sun, even though it's relatively low, it's winter, still the angle hits this sloped surface of the Sierra Nevada, and because that gives us enough sun power, like you can imagine, if this would be flat, the sun rays would come much more flat, hit the surface much more flat, but because the land is raised upwards, the sun hits much more vertical, a bit like it would do in summer. So we get an exceptionally high power of sunlight here locally because of the slope of the mountains, comparable maybe to the Canaries. And that's why this sun power, when there are no clouds, has the possibility to warm up this colder layer underneath. And that's why we get these incredibly high temperatures. So practically when this would be heated through these 16 degrees in 2 kilometers, and then we get 1 kilometer and the sun can heat it up completely because there are no clouds and south slope, we would get 26 degrees. Again, the 1 degree per 100 meters. If the sun manages to heat all this up, we will get 26 degrees in 1000 meters. And that's practically the situation we have here. We currently have 27 in 800 meters. So that's very close to that. Yeah, so maybe I hope I could explain something and you get an idea now.